Okay, we will begin. Okay, so as Karthik said, it's nothing but testing the one part of software testing is testing the efficiency of the product. The other part of software testing is whether we are developing a product as per the user requirements, or whether that product, like while designing a product, so we will have a set of requirements, and once the product is developed, we will map our requirements, that is the requirements that is given uh, in the beginning, and the product that is developed. If there is any deviation, and like if through software testing we can identify whether there is a deviation, and we will also find bugs. Okay, so the main aim of software testing is so uh, to release a product which is bug free. So testing is nothing but mapping the expected requirements was against the against the actual requirements. So at the end of our testing, we will report bugs, which is nothing but deviation in the requirements, or deviation in the functionality that was initially specified in our SRS document. That is, SRS document is nothing but requirement specification document. Yes, checking the quality of the product. Correct, correct, Ramya. Sorry, just a minute. Okay, so this is, so as I said, like it's a method to check the actual software matches the requirements and to ensure that the product is bug free. Okay, so like in software testing, to evaluate this deviation, or to evaluate between the expected and the actual requirements, we adopt different methodologies. One is through manual testing, the other one is through automated libraries or automated tools. Okay, so the main aim of both manual as well as automation is to release a product which is bug free to the customer. Correct. So this is the software testing is nothing but checking the quality of the product, and to ensure whenever a product is delivered to the customer, it's not a buggy product and it's bug free. Okay, so this is called as software testing. So next we will see what are the benefits of software testing. Okay, so benefits in a sense, like what can be the outcome of software testing. First is cost effectiveness. Cost effectiveness, can someone relate to cost effectiveness? So assume like your like assume like you're developing a product, and if there is a product with regard to payment, or which is in direct relation to the revenue of that organization. Okay, so normally, like assume in Amazon. Okay, while you are adding a product to the cart, and like while you are trying to make a payment, so if there is any bug during payment, or if there is any bug which is causing the price of the product in a decreased price. So, like if that's the case, then imagine the impact from a cost perspective. Okay, so there are many retailers who are selling in Amazon, correct? So assume like for some of the retailers, the price is getting changed, or the price is reduced. For example, if the price of the product is 100, and if for some retailer it is showing us 50 in the Amazon product, then it's a loss for the retailers as well as for the company. So cost effectiveness is one very important outcome of software testing. So software testing helps to find the bugs at an earlier stage, so which helps in fixing before it's getting released. Assume like we are missing this bug with regard to this price mismatch, and like if you are releasing, then think of the impact that is for the customer, for the retailer as well as the organization. Customer would be like, or there are two things. One, that cost um, should be taken by the Amazon, or by the retailer. Okay, so this is one thing, and the second thing is security. Assume like if there is a bug which is exposing the details of all the user details from Amazon or any other product. Okay, so the security of the product is very important. So there are many bug bounties or bug hunters, pen testers. Pen testers are nothing but the pen testers are the testers who do all the security, and they find the vulnerability of a product. Okay, and they ask for money. Okay, there are pen testers who are, and they have a community as well. Okay, so if our API, if our application is exposing the customer details, then it's a bigger loss, and it's more than a loss. It's related to integrity, data integrity, which would break the trust between the product, between the company and the customers. So security is another factor, which is the outcome of a proper software testing. Then product quality, as usual. So we can't at any cost, like we can't let the quality of the product down. Okay, so at any cost, we should release our product, which is which is a bug free. Okay, then customer satisfaction. If we are having, if we are releasing a product with good user experience, and if there are no bugs, and if the customer is able to use our product seamlessly, then it's called as customer satisfaction. Customer satisfaction at the end of the day, either it's a B2C or a B2B business. B2C is nothing but an Amazon, whereas when the business happens between corporates, it's called as a B2B. Okay, when the business happens between corporate companies, it's called as B2B, whereas when the business happens from to customers, to normal people, it's called as a B2C. Okay, so end of the day, if a customer is able to use our product seamlessly, then there are chances of that customer having a higher trust from our product, and like basically it will lead to the customer satisfaction. So these four are the major. There are other benefits as well, but out of all the benefits, these four benefits are very critical for any software testing. So the first is cost effectiveness, the second is security, then third is product quality, and the customer satisfaction. Security, cost effectiveness are like all the three plays a vital role, and which is a major outcome of software testing. Okay, like we should be damn sure that at the end of software testing, or at the end of a product is being deployed in prod, these four things should not be like a loss from our end. So we should have always, like our product should always have four checks. That is, one is we should not let the bug to break in production. Then there should not be any security vulnerabilities in our software. Then we should ensure that the product is matching our requirements and it's bug free. The third is customer satisfaction. Customer satisfaction is one major thing which will build trust within the customers. Correct? So any other thing, like any other queries till now? Okay. Now, like I will move on to then now we have seen software testing. Now we will see where exactly software testing comes into place. You might have studied in your college, or like you might have heard about this SDLC, which is nothing but software development life cycle. Correct? So like for any software, for any product or any feature, it can be a small feature, but that feature goes through this stage. That is, like we analyze the requirements, then we design, then we implement, testing, evaluation. These 5 stages definitely any product would have gone through. Okay, it can be a smaller product, it can be a bigger product, it can be a smaller feature in a product. All this would have gone through this phase. So I will give a brief overview of what each stages speak about. Okay, in each of the stage, what we do and what is the outcome of at the end of each stage. Analysis. So analysis. So in a software company, like there would be product managers or product owners. Okay, so the product owners are the persons who would speak with the existing customers. Okay, so existing customers in a sense, like who are using our product. Okay, other than, so they would speak with the existing customers, and with sales team they will get the requirements. That is, so the good to have features would be got from this conversation. So so product owners are the persons who would interact with the customers or the sales people and get all the requirements. Okay, get the requirements, what and all is required in this product. So it can be 10 features, it can be 15 features, it can be any number. Okay, but the first level of conversation is this product managers, or in some cases business analysts. They interact with the customers and they get all the features. Okay, then at the end of the analysis phase, what they do, they decide upon the features for that particular they discuss upon the requirements for that particular feature or that particular product. Okay, that's the outcome of analysis. Now comes the design phase. So design phase is nothing but, so the developers, the QA and the product managers would decide upon what majorly here the conversation would happen between would happen between the development team, and they would decide upon the tech stack they are going to use, which front end technology they are going to use, which back end technology they are going to use. Okay, and like and there can be a number of, they assume there are 10 requirements. Okay, so during this conversation they will finalize, they'll come into agreement that these are the things that are being picked for the first cut of release, and this would be the tech stack for tech stack for this particular requirements. So at the end of design phase, and they will also create a higher level skeleton how it's going to be implemented, and they would showcase it to different principal architects to to analyze the design how it's going to be implemented in the product. Okay, so design phase is nothing but deciding upon the tech stack and designing an overall skeleton of the feature that is going to be implemented in the product, and they would get approval. There will be several rounds of discussion. They would get approval with the senior persons, that is the architects, and they're now everything is being set. The stage is set. Now they are going to implement. There comes the implementation stage. Implementation stage is nothing but here the person should be now they have decided upon the skeleton and everything tech stack. Now the developers would be working in teams, and they would implement the requirements that was agreed previously. Correct. So this implementation stage is is nothing but hard code level implementation. At the end of implementation stage, the product would be developed, and it would be in a form of dev tested product. Okay, dev tested in a sense like the developer would have written the code for a particular feature, and on behalf, even before the build is getting delivered to the QA team, developer would do one round of testing. Okay, so that's called as a dev testing. So in dev testing, there is a methodology. We'll speak again in the upcoming slides. For now, assume that dev testing is a testing which is being done by the developers to ensure the major functionality of the product is not broken. For assume that now Google is developing a feature to attach inline image. Okay, so at the end of implementation, or what does dev testing means is like they would just try to just try to do an inline image in the body of the mail, and they will try to send. Without this, if that feature is getting delivered to the QA team, then there is no use QA team testing that, because there is initially, that is the intent of that feature is itself not passing, right? So there is no scope of testing there. So again, it's a broken code. So in today's world, like developers just do one round of dev testing even before even before the product is delivered to the QA team. Okay, now comes QA team. Okay, so now we are the QAs. Okay, so we are assume like we are going to do manual testing. Okay, so what and all we will do? So we have the requirement specification document. Okay, so during the implementation and during the design phase, I forgot to say one thing. So during the design phase and during the implementation, when the developers are implementing the code, we testers, what we will do is we will write test cases for the feature that is going to be showcased to us, or that is going to be given to us for testing. Okay, so we write test cases. When the developer start code, when the developer start to code, we will start to write the test cases for that particular feature. And again, like we will also review. There will be several rounds of review, and once that is done, once the build is delivered, by the time we will have the test cases ready against which this product or this feature is going to be evaluated. Correct? Agreed? So at the end of testing, so we will run our test cases. That is, we will execute our test cases against the feature, and like if there is any deviation, we will file it. We will call that as a defect. Okay, we will call that as a defect. We will assign it to the developer, and developer would be fixing it, and he would be giving us the bug fix build. Again we will be testing that. So end of testing is nothing but we will be evaluating whether the product is being built as per the requirement specification document through test cases. Okay, once that is done, once the testing is completed, we will release the product. Okay, if it's a B2B, if it's a product that is being used by other organization, So there would be maintenance phase. Maintenance phase is nothing but there would be resources from our team in their workstation to ensure that the transition is smooth. We will give all the necessary KT how to use the product, and if there are any bugs that are being reported that time, we would we would fix it immediately, and like we will share the necessary KT to the team. So I will repeat once again the life cycle, that is the software development life cycle. So the software development life cycle starts from the analysis stage. Analysis stage is nothing but the business owners, okay, or the product owners would speak with the sales team and the customers to fetch the requirements that is needed for this particular product. Then at the end of analysis phase, they will have the set of requirements, and the design phase is nothing but, so they will the developers would decide upon the tech stack that is going to be used for the set of requirements, and they will also design the skeleton. Skeleton is nothing but a high level workflow of how the product is going to be designed, and there will be several level of approvals from architects signing off for the design that is being developed by the developers. Then comes the implementation. Implementation is nothing but this higher level, higher level view would be split into small modules, and several developers would be working simultaneously, and they would be developing the product. In the meantime, like we would be writing test cases from the using the requirements, that is requirement specification document as our benchmark document. So we will be writing, so that document would serve as a benchmark again for the developers as well as for the testers. The developers would be writing the code to develop that feature, whereas testers would be designing test cases. Okay, once that is done, testing phase is even before this stage, the developers would do one round of dev testing even before the build is delivered to the QA team. Now, once the build is delivered to the QA team, what will the QA team do? QA team will test that product against the requirements. Okay, then comes the evaluation. Evaluation is nothing but evaluation or the maintenance phase is nothing but once it is done, like it will be deployed, it will be pushed to production, or it will be shared with the other business or other organization who is going to use our product, and the necessary KT, all the transition would happen simultaneously if there are any bugs, and we would be working from their workstation to ensure that during the initial phases they are not facing any issue. So this speaks about the SDLC. Any queries till now? Okay. Thanks. Thanks, Mohammed. Thanks. Okay, super. Sorry. Okay. Now, like as I said, like now we will see the methodologies that is adapted in software testing. Okay. So basically, guys, software testing is split into two types. One is functional and non-functional. Functional, as the name implies, functional testing is nothing but checking the functionality of the product or the feature. Correct. So under functional testing, there are different methodologies we would adapt to test the product. Okay. Whereas non-functional testing is other than functional, other types of testing comes under performance testing. All other testing comes under non-functional. Correct. So very simple. From the name, the literal meaning of the name, functional testing is nothing but in this functional testing, we will focus only on the functionality of the product. Okay, and test. Okay, whereas in non-functional testing, other than functionality, what and all can be tested, we will test under non-functional testing. Correct. So in functional testing, okay, in functional testing, there are different types of testing methodologies. Okay, so the first one is called as a smoke testing. Okay, very simple. So assume there are 10 features in our product. Okay, assume there are 10 features in that product. Okay, and for the 10 features, there would be high-level use cases. High-level use cases are nothing but the critical functionalities. For example, assume one of the features for any product, login functionality is very critical. Correct. So the high-level use case of a login functionality is validating whether we are able to log in through correct credentials. Okay. So that is the important use case. Okay. Important or a major use case. Okay. So in-depth use cases can be correct password, incorrect correct username, incorrect password, incorrect username, correct password. Then testing the password strength. So this can be other use cases, but the major use cases are only the high-level use cases are the most critical test cases. Okay, smoke testing is nothing but doing once as I said, like once the build is delivered to the QA. So even before doing in-depth testing, okay, so even before doing, like for example, for these 10 features, assume there are 500 test cases. Okay, in smoke testing there will be hardly 50 test cases. Okay, we will first validate that build. Okay, we will first validate that build against these 50 test cases, which is nothing but high level test or the major test cases, critical test cases in each and every feature or in each and every module. Okay, we will validate this. Okay, we'll, it's passing, if all the 50 test cases are passing, we will pass on that build to regression. Regression is nothing but assume, as I said, like there are 10 features in this product. Okay, and if the developers are working on on the 11th feature, this 11th feature should not break the existing 10 features. Correct? The addition of new features should not break the existing functionalities of the product. Okay. Okay. So as I said, like if you are in send mail, if the developers are working to attach an image inline, this incoming feature should not break the normal send mail feature, sending a mail without images or without any attachments. Okay. So the new feature should not break the existing functionalities, and it's called as the in-depth testing. So as I said, like 50 use cases for smoke testing, and this 500 use cases completely would be tested in regression testing. Okay, I will repeat once again. Smoke testing is nothing but high level or the critical use cases in each of the functional, in each of the feature. Okay, so if there are 500 test cases, assume there would be 50 use cases only for this 500 test cases, critical use cases. Once the build is delivered to the QA from the development team, that is after the implementation stage is completed, here we will validate that build against these 50 test cases. If the 50 test cases pass only, we will pass on that build to regression testing. As I said, regression testing is nothing but the incoming feature, that is a new feature that is being developed, should not break the existing functionality. Assume there are 10 features, already there are 10 features in the product, and the developers have developed a new feature, 11th feature. Okay, the incoming 11th feature should not break the existing 10 features. Okay, and moreover, this 10 features should be evaluated in depth. Okay, here all these 10 features should be evaluated, which is nothing but 500 test cases would be executed against that build or that product. Correct? Am I clear till now? You're understanding the difference between smoke and regression? Yes, if you're understanding, give us a thumbs up. Okay, definitely. I will repeat. See, I will go to the next phase. Okay, so we saw implementation phase, right? So implementation phase is nothing but the developers would have developed the product. Okay. Now, once the product is developed, they would give our build. They would give the build. Build is nothing but the product that was developed. We are going to test that feature, test that product. Okay. So in this testing, okay, what we will do is smoke testing is nothing but when a build is delivered from the development team to the QA team, we will validate only the high-level use cases. That is the critical use cases for the existing product. Okay, assume there are 500 use cases, 500 test cases for the complete product. And if there, as I said, like for a login functionality, first we should login should work for the correct credentials. Then we can check for incorrect username, incorrect password, then password strength. Everything can be checked in detail afterwards. But the login should work for the correct credentials. Okay, so smoke testing is nothing but high-level use cases are the important use case in each of the functionality. Assume there are 10 functionalities in a product. So assume there are 10 high-level use cases. That is 10 for each functionalities, and it can be 10 or it can be 5. So just for your better understanding, I'm saying 10. Okay, so smoke testing is nothing but high level use cases for the complete product. Once that is done, only that build would be given for regression testing. Regression testing is in-depth testing. So assume that if login is not working, then what's the use of doing in-depth testing in that build? Correct. So first login should work. That is the reason for us to validating with the high level or the critical use cases. Okay, am I clear now? Okay, got it. Sorry, guys. Okay, so smoke now there is no not much difference between smoke and sanity. Now you know the difference between smoke and regression. Smoke is high level testing, whereas regression is in-depth testing. Okay, so now sanity is also high level testing only, but the place varies. Okay, first when the build is delivered from the development to the QA team, we will perform smoke testing. But when we give sign off, when we do our in-depth testing and when everything works, okay, now when we push it to the production, okay, after the build is pushed to production, we will once again test the high level use cases. So testing in production, the testing in prod is called as sanity testing. So smoke and sanity are more or less the same, but the place varies. Okay, smoke and sanity is nothing but testing the high level use cases. Once we testers have tested everything, yeah, have tested everything in depth testing, and we have given sign off saying that this build can be delivered to production. Okay, this build can be delivered to production. Okay, if we give sign off, then the developers would push that build to production. Now what is happening? Now there were 10 features. Now there was the 11th feature that was developed, and we have tested that completely, and we have pushed to production. So in production, there will be 11 features. Correct. So in these 11 features, now if we do high level testing on the prod build, which is nothing on the production build, it's called as sanity testing. Smoke testing would be done when the build is delivered to the QA team from the development team, whereas sanity testing would be done when the QA team gives sign off and when it's pushed to production. When the testing is done in production, it's called as sanity testing. Got it? Okay. So unit testing is nothing but unit testing is nothing but, as I said, like dev testing. I was speaking about dev testing, right? Even before the build is delivered to the QA team, there would be a dev testing that would be done by the developers. Correct. So here the developers would adopt a methodology called as unit testing. So normally manual testers, okay, or automation, mostly dev testing would be unit testing would be done by the developers. Okay. So unit testing is nothing but, so as I said, there are 10 features and the developers are working on the 11th feature. Correct. So in the 11th feature, what they will do is they will in code level, this will happen in code level. So this 11th feature, okay. So now the developers would give different input to the they will isolate this piece of code, they will isolate this piece of code, okay, and they will test the code against different input parameters to see whether the code is working as expected. Okay, unit testing would be done by the developers. Okay, unit testing would be done by the developers to ensure that the implemented code is working as expected. Okay, so they will isolate that piece of code, and they will there are different unit testing frameworks available in market. So they will, with the help of those unit testing frameworks, they would supply different input parameters to their code, and they will validate the code whether the code is returning the expected output. This is called as unit testing. Whereas integration testing is nothing but, so the developers, as I said, like for any feature, for any product, there will be several, at least there will be some 3-4 developers from backend, 3-4 developers from front end. Okay, they would be working on that. So then what they will do is they will try to integrate all the development, all the fragments into one complete code, and that's called as, and once that is done, we will once that is done and once that is delivered to the QA team, integration testing is nothing but we will check the interrelating modules. Okay, interrelating modules. So assume that the new feature is for um, attaching inline image. Correct? I said inline image in the body of the mail. Okay. So this integration testing what we should test is we should test all the attachment types. Okay. From computers, from all the attachment types, all the different image types. So integrating integration between modules. This new feature at code level to what and all modules it's being integrated. So all those integrated modules we will be testing across. This is called as integration testing. So the developers would be developing in bits and pieces, and they would be integrating and giving to the testers. So this new feature, now we should analyze. We should speak to the developers to understand this feature where and all it would impact, where it has been, where the code has been integrated, and where and all this new feature would impact. So we should understand the scope of testing, and we would do one round of integration testing here. Okay, so integration testing is nothing but this new feature where and all it has integrated with the existing feature. There and all we will have a thorough round of testing. This is called as an integration testing. Okay, under non-functional, this comes under all this, and there are several other testing methodologies. In brief, these are the major things that we'll focus on. Under non-functional testing, as I said, in non-functional testing, other than functionality, if we evaluate our product, then it's called as non-functional testing. Okay, other than functionality, what the speed of the product, correct? The performance of the product. Okay, so these are the things which comes under non-functional. So performance testing is nothing but we will design our product. Okay, for every product there would be the number of servers that would be assigned in any of the cloud platforms. Correct. So AWS or Azure, any of the cloud from Google Cloud. So they would have assumed the number of servers. So performance testing is like how quick our product is responding for any query. Okay, this is called as a performance. Load testing is nothing but we will assume that the audience for each product varies. Okay, so assume for Amazon on a big billion day, for a Flipkart, okay, for a big billion day or any other campaign, so the number of users would be huge, right? In that case, they would be handling. For example, assuming Hotstar, we are watching a match. Okay, so the audience would be more for India versus Pakistan match, definitely. So in that case, their servers and everything should handle, and there should not be any delay. There should be less buffer. So these are the things which comes under performance testing. Okay, so load testing is nothing but so if the application is designed to handle a load, for assume 1,000 users, we will give this load. We will give this load and we will test. Okay, and there is one other testing called as stress testing. So stress testing is nothing but beyond the load, we will if the application is designed for 1,000 customers. If we give 1,100, if we give the number of users as 1,100, how the application is behaving and where is the breaking point of that application, and how well the application recovers after the breaking point is called as stress testing. Okay, so performance testing is nothing but basically how well the application responds to different to the number of users. Okay, this is called as the performance testing. So we saw the different testing methodologies, which is being adopted to test a product. Now, like as I said, like at the end of testing, like while we are in the process of testing, what we find is bugs or defects. Correct. And there is a specific life cycle a bug goes or a defect goes through. Okay, so like normally, like when I found a bug, okay, what I will do, I will raise it. And there are different bug raising, there are defect tracking tools. Okay, like Jira. There are many tools, Bugzilla. There are many tools across industry. So we will be using this tool to raise our bugs. Okay, or a simple Excel can be used to raise our bugs. Okay, once this bug is raised, okay, it will be in the status called as new. Okay, once the bug is raised, it will be in the status of new. There would be in some organizations there is a triaging team. Triaging team is nothing but mainly a product owner or a senior member from a QA team. What he will do is like he will assign that bug, because like as I said, on a particular feature, there would be several developers, would be several front-end and back-end developers who would be working on that particular feature. So in that case, they should allocate this bug to the appropriate developer. They should not allocate to a person who has not worked on that particular product. Okay, or not on that particular product, who don't have context on that particular issue. Okay, so assume there are 3 developers working from front end and 3 developers from back end. Okay, so if you have found a bug, and this bug might be related to a front end developer or a back end developer, not to all 6 developers, right? So that is where, like, first they will filter out whether it's a back end bug or a front end bug. If it's a front end bug, then they will allocate that bug to the corresponding developer. Okay, then the status would be changed as assigned. Okay, one assigned in a sense like it is being allocated to the developer, or the status would be changed to in progress. Okay, once the bug has been reviewed and once the bug has been once the bug has been fixed, it would be reassigned to the tester for us to retest that bug. Okay, once we retest, what will do? Can be 2 resolutions here. If a bug is retested, it can be closed. It can be gone ahead and close that. We can close that bug. Okay, or else if the bug is still reproducible, what we will do is we will reopen that bug and assign back to the same developer. The developer who has fixed that issue, if you have what at the end of retesting, if you face the same issue, we will go back and assign the bug to the same developer. Okay, this is the general life cycle. Okay, when a bug is being raised, okay, it will be in the new status. Once it is being assigned to the developer, it will be in assigned status. Then the developer would fix it. After which we testers would be testing that. Once we have tested that, we would be moving that bug to closed state, or we would be, if the bug is still, if the issue is still persists, is still reproducible, we will assign back, we will reopen that bug and assign back to the developer. This is the general flow. There are other flows. Okay, even before, as I said, like there would be a we call it as bug triaging. There can be a product owner or a senior member from the QA team. There, like if a bug is reported, he has the authority, or he will validate. There can be 3. Say one is rejected. There can, like, out of that particular tester would not have knowledge. It would be in the SRS document. It would be by design. Okay, that would be the expected behavior, and you would have falsely raised that bug. In that case, the triaging team, okay, triaging team would reject that bug. Then deferred is nothing but they would accept it as a bug, but they won't fix it for this particular release. Okay, this had been deferred to the next release, something like that. Whereas duplicate is nothing but like the same bug. As I said, like if there are many developers working on that product, there will be at least 2 or 3 testers. If there are 6 developers, there will be at least 2 to 3 testers. If the bug has been reported by the other tester, then we will close that as duplicate to reduce the effort to the development team. Okay, rejected is nothing but that's not a bug. Deferred is nothing but they have accepted it as a bug, but they are postponing it to the next release. Then duplicate is nothing but that bug has been already reported by some other person in your team. Okay, this is the bug life cycle. Bug life cycle is nothing but the different stages a bug a defect goes through. Okay, now we'll come to why do you think we should move towards manual testing, towards automation testing? We are doing manual testing. Okay, and understood. Like we are doing manual testing for the first year, second year, but we can't stay in manual testing forever, right? So we need to switch to automation. There are some factors. Okay, so you can also feel free to post your view in the thread also, in the chat also. Okay, so what are the things which makes us to think that we should move towards automation testing? Okay, one is, so as you know, like there are 500 use cases. I am testing 500. I have manually tested these 500 test cases, and that I'm given sign off. Okay, now the 11th feature is live. Now assume the 12th feature is coming. Okay, now for the 12th feature, there will be some 550 test cases, because this 11th feature there will be 50 test cases that has been newly added for the 11th feature. Again, if I do manually, just consider the effort. And if you are going to do 5 to 6 releases a month, then think of the effort that is required for the tester to test all the test cases for each release. Okay, so as you know, like it's a tedious process, and like it takes more time. So that is one strong reason why we should move to automation. Then human errors. See, we are humans, and like see, we tend to make errors. Correct. So we design script. Okay, script like machines or scripts don't make errors. We give the intelligence to the script, and they do what that particular script should do. They won't deviate. But we human, there are several distractions. Several assume like assume like for this week we have tested 500 test cases. For the next week we have tested 500 test cases. For the third week if we test, it's natural. It's a human mentality like to miss somewhere, right? So it is we are prone to errors. Okay. Now, as I said, it's time consuming, and to maintain test cases, it's going to be time consuming, and it's costly to maintain manual. So assume like for running this find test cases, assume there are yeah, there is one release for each week. Okay, then assume like as the number of features grow, the suite of the regression use cases also grow. Regression is nothing but in-depth testing, and the regression test cases also grow, and that so which in turn makes us to onboard more manual testers, which is not effective, efficient. Okay, then like as I said like earlier feedback. Okay, so assume like there are 500 test cases. Okay, now today we'll do 50 test cases. Assume like we are doing 100 test cases per day, 100 test cases tomorrow. Now now there is a bug in the 40th test case, we will be identifying at the end of 50 days. Whereas if it's an automation script, okay, so like we will be working the 8 to 10 hours per day. Okay, automation script, we can schedule that script at the end of day. So before we come the next day, the report would be generated, and there is an error in the suite, it would have thrown, and like we would have, and that error would have been reflected in the report. Okay, so test reusability, the same thing, test reusability. So for every release, okay, we can add a few more automation use cases for the new feature, and we can run the same test again and again. Correct. So which is nothing but test reusability. So these are the main reasons why we should move towards automation testing. So I understand manual testers, like automation script don't have intelligence. We design the script the way we want it. Okay, so definitely manual testing is required, and manual testers are required because like scripts can't think out of box. We can only think. Moreover, manual testing like the alignment, UX alignments also there are several tools. UX, the customer experience, those things can be caught only by manual testers, not by scripts. Okay, the manual testers are required. There is no debate about that. But what we can do is like that the things that we are doing repeatedly can be automated, so that like two things are there. Like that particular feature or product would be released faster. We would have a faster release cycle. The other thing is like manual testers can spend more time on thinking out of box. Okay, if you are not putting automation in place, what will happen? We will do the same task again and again, and we won't have that time to think out of box. Okay, what we'll think? Okay, we will execute this 500 test cases, then we will push it. Like we won't have the time to think out of box because we would be already struggling to complete the test execution, right? So these are the strong reasons why we should move towards manual testing. So move towards automation. Okay, now automation scope. Okay, automation testing scope. Okay, so now we have said like automation is essential, but there are different things where we can automate predominantly, guys. So we can most of the applications are web applications. Okay, loads with HTTPS. Okay, so for we can automate web application, then mobile apps. So now everyone is having advanced smartphones, so like everything is done from the mobile. So definitely for any application there should be a for at least for more 90% of the companies, they have a web application as well as a mobile application. We can automate. There is a scope for mobile automation also. API automation. See, mobile automation and web automation speaks about the GUI of the application. correct. Click on login, web automation. All speak about the in mobile and web automation. What we do is like we test the UI of the application and we navigate to different screens through the UI that is present in the application. Whereas API testing is nothing but, for example, okay, assume we are clicking the login button. Assume we are clicking the login button. At the back end, what will happen is for login, there would be, once we enter username and password, using GUI scripts, using Selenium or APM, what we will do is we will enter the username and password. We will provide the test data and we will enter. And once we click on login button, it will validate. That validation is happening through APIs. That validation is happening through APIs. And there are several frameworks for testing, for API testing. Okay, so all the validation, both front end and back end, speak through APIs. Okay, but what from a UI perspective, what we will think, we are entering correct username, password. Once I click on login, we should go to the home page of that application. We will validate whether through Selenium or through any other UI automation tool. We will validate whether we have navigated to the next page, but we are not validating the API. Okay, so API testing is another type of automation. The other is performance testing. There are again open source tools, JMeter, and other tools. Performance testing. So performance testing basically speaks about how efficient is the application, how fast the application interacts to the customer, to the users. Okay, correct. So these are the different areas. Now there are so many areas. Okay, like IoT automation. There are many areas where automation can be put in place. Okay, so predominantly, like in context to this course, like we speak about the things that can be automated from a manual testing to an automation career change. Okay, so web automation, mobile automation, API automation, and performance testing. Okay, now we will see. Now, as I said, like there are different tools. Okay, there are different tools. Now we will see what is. Now we are going to focus on Selenium, which is nothing but a web automation library, which is available in the market. Okay, now we are going to. There are different tools. There are different tools that is available in the market for web automation. Okay, there are both priced as well as open source. Okay, there are both priced as well as open source. But like there is a difference between a proprietary software as well as the open source software. Guys, give me 1 minute of time. I will have water. Sorry, guys. Thank you. Okay. So, like we were speaking about the different automation scope. Okay. So, with regard to the webinar, what we have planned is Selenium. Okay. Selenium is basically a web automation library, which is open source. There are several tools. Okay. Both proprietary as well as open source available in the market. Okay. With regard to proprietary, there is LeanFT, which can automate both web as well as web and desktop applications. Proprietary are nothing but licensed tool. So for every user, we should be paying. And in open source, there are different tools. Okay, there are different like Selenium, Then there is a tool called as Karate, then Cypress, then Playwright, Puppeteer. There are several tools available in the market from an open source perspective as well. But why we choose Selenium? Okay, so because of its these are the main reasons why we have chosen Selenium over other preferred web automation tools. One is multi-browser compatibility. So we can run the same test again Chrome browser, Firefox browser, and Edge, and Safari browser also. Okay, so multi-browser support. Okay, then is multi-language support. We can write our test as per our uh, programming language. That is as per the programming language we know. It can be Java, Python, C Sharp, JS, JavaScript. Like it allows that. So we need to download that particular Selenium library, Selenium binding from the Selenium website, and we can very well use that. Okay, then comes the speed and performance. Speed and performance is like there are like in the open source, like the Selenium tests run at a good speed. Okay, and the major thing is the community support. Okay, Selenium, it all began in the year 2004. Okay, it was actually a JavaScript engine. Okay, it was a JavaScript framework which was developed internally for their company, for a company, and like then it became at a open source. And then when it became popular was when Stewart, he was an engineer. When he started to look into this project, it gained popularity in 2008. From 2008 only, like the Selenium gained popularity, and it's been in the market for a while. Okay, and it has a huge community support, very huge community support, and there are several releases that's happening like very frequently. Then open source and portable. Okay, and works across different OS. OS is then like we can reuse the same test in Windows, Mac, Linux. It works fine. And this also provides the other important thing is like Selenium is can be easily integrated with other unit testing frameworks that is available in the market. Okay, it can easily integrate with other unit testing frameworks like TestNG or JUnit or BDD frameworks like Cucumber. And like the commands are self-explanatory. Most of the commands are self-explanatory. And like when you move towards automation, definitely there will be a reduced time in the test coverage. And nothing specific to install. It's just a library we need to download. We need to import to our Java project. That's all. We can very well play with the start writing the test. Okay, am I clear till now? Okay, guys, I will move on. Okay, so inside Selenium, okay, even before going towards inside to the architecture of Selenium, I just wanted to see what and all what are all the components inside a Selenium. Okay, once you download the library, okay, you will get Selenium WebDriver and Selenium Grid. Okay, it's a built-in functionality. Selenium IDE is a tool which is nothing but a record and playback tool that is available in the market, and we can download for the browser we need. It's very simple. Okay, I can just search for Selenium IDE in the browser. If you can search for Selenium IDE in the browser for Chrome, okay, once you, like, is it visible? Is it visible? Okay, which programming language? Again, Shweta, it depends upon the company, Shweta. Okay, so like most of the companies use Java. Now, like Selenium with C Sharp, and C Sharp is also gaining importance. Okay, it basically depends upon the tech stack the product has been developed. If a company has implemented, if the backend of the product is Java, then very well we will go with Java. Okay. If the backend, there are some companies who have used Python. as a backend. There we will use Python, Selenium with Python. It basically depends upon the company we work with. Okay, in all most of the networking companies, they will use Python as a programming language. Okay, now C sharp, Selenium with C sharp is also gaining importance. Okay, thanks, Ramya. Okay, so if you see Selenium IDE it's a very simple tool that is available in the market. So you can just type on Selenium IDE for Chrome. If you see, it comes as an extension also. So I guess I have already installed. Okay, so if you see now, now I will remove add to Chrome, add this extension. Okay, so now this is added as an extension. Okay, pinned it. Okay, very simple, guys. So this once I click on this, a window will be open. It's nothing but a record and playback. For simple, very simple task, we can use Selenium IDE. Okay, so just I will create a record a new test as a project. I just create test one. Okay, and the base URL. Base URL is nothing but the URL which I'm going to test. As I said, this is a web automation tool. So I'm using I'm just entering www.google.com. And once I start this, once I start recording, this automatically this Google browser will be launched. Okay, if I'm saying webinar on Selenium ID, if I enter and I am Simon's, I'm just putting this entry. Okay, I think like now everything is now what and all we are doing, it's getting recorded. Now this button using which I can stop it, and I wanted to give a test. Okay, just named it. Okay, now I can save this or export. See, these are the things. See, just what I will do is I've I started recording. I did this sequence of steps which got recorded. I've stopped the test and I've named the test. Now if I click on this play button, it will automatically do what I've done. Are you able to see? Are you able to see? Okay, ID page not visible. Okay, guys, sorry. Okay, so I'll once again do. So as I said, like it's a plug and playback tool. Now now is it visible? Now is it visible, guys? Even said like is it visible? Okay, thank you. Okay, now I'll rename it test two. Just and the base URL, the URL where I'm going to do the test. Just enter Google and I'm starting recording. If I start recording, what I'm doing is webinar on Selenium, and I'm clicking this one. I'm maximizing the window. Okay. I'll stop this test. Okay. Stop recording. Test two. Okay. Just like this. Morning. I'm starting the recording. So I'm just putting webinar on Selenium. I'm expanding the window. What is happening? Okay, assume like till now, like the steps which I have performed. Okay, so I'm passing the step. Okay, now I have passed the recording. So see what and all I have performed, that has been recorded. Now if I again run the test, now if I again run the test, or like before doing this, now if I run the test, now if I run the test, it will automatically. Okay, so and like now I can even export this test using export option. I can see I have different like if I have if I want to export the test as a Java test, I can use using Java. If I want to export this test as a C sharp, then it can be done. Then Python it can be done. It can be done using Ruby also. Like if I export, this test should be visible. And now I'm putting as Java in it. Yeah, testing. If you see, it is downloaded as a class file, Java file. So these are the steps. Like we launched Google. Now we expanded the window. We typed something and like webinar on Selenium, and like without doing anything, the code is automatically written by Selenium IDE. So this is one advantage, but there is a biggest downfall is we won't be able to parameterize test data. So the challenge here is like, for example, we won't like assume if it's assume a login functionality. Okay, in the login functionality, like we can give sign off only once we test the login functionality completely. So we need to run the same function. We need to validate the same functionality against different test data. That is correct credentials, incorrect username, correct password, then correct username, incorrect username. So test data matters. Okay. So we can't do parameterization using Selenium IDE efficiently. So that is the reason we will move on to WebDriver. WebDriver is again a library. Selenium IDE can be used for simple tasks. Okay. You can use Selenium IDE for simple tasks, for automatic simple tasks, which is basically which can reduce some amount of effort. Means we can use Selenium IDE, we can record and playback. It will do the job. Selenium WebDriver is the thing which is the most sorted out library. So we will be showing demo in the upcoming slides how we use. And Selenium Grid is nothing but, so for examining parallel execution, assume there are 500 test cases. Assume there are 500 test cases, and assume the time that would be taken to execute sequentially. That is one after the other. Only first test case would be executed. Only once the first test case is completed, if we run the second test case, then after the second test case, third, 4, 5, 6, 7. If it goes on, what will happen? Assume the time. Assume if it's taking at least a minute to execute a test, then it will take around 500 minutes to complete that test automation suite, right? So in this case, there is an option that is being provided by Selenium called as Selenium Grid, which is nothing but we can parallelize our test using a multi-threading concept in Java. Like it's built in. It's built in inside Selenium. There is a corresponding jar we need to download without a Maven dependency. For now, like we will be downloading, and like using Selenium Group, there would be hub and node. Okay, hub and node concept. Hub means he would be the controller, and nodes are the computers. So what we will do is, if assume there are in a distributed system, assume there are 500 test cases. This there will be a hub who would control, and there are 5 nodes. 5 nodes can be 5 systems or 5 servers. Okay, these 5 servers would be registered to hub using some. There is a registration mechanism using which we can register these nodes to this hub. And what will this hub do is, this hub will have 500 test cases. This and it will have a set of registered nodes, right? So this hub will allocate the test to this nodes. If there are 5 nodes available, 5 servers available, what it will do is it will allocate the first 5 tests in a random order. Okay. And if any of the node, or if that particular test is completed, then it will allocate the 6 test case automation test case to the free node. It will go on. Okay, so Selenium Grid is used for parallel execution, which is like in Selenium 4, it has been completely like the architecture has been revamped, and the Selenium Grid, like the execution time will bring down to a larger extent. Okay, so Selenium Grid is one component in Selenium. So this is the major component. Selenium IDE is a record and playback feature. It's a Selenium extension. It is available as Selenium extension. You can play around with this. Selenium WebDriver is again, which is one library where we can automate. And Selenium Grid is nothing but an extension of Selenium WebDriver. And this which is Selenium Grid is used for parallel execution. And like there is an hub and node concept. So nodes would be registered to this hub, and hub would act as a controller who would distribute the test to the registered nodes, and they will proceed the execution. Okay. Now we will see the architecture. Okay, Selenium architecture. So this is the architecture, guys. So now previously, like we had imported one script, right, from from Selenium IDE. Okay, that script, right? That's the Selenium script. Think that is the actual Selenium script. Okay, so we develop using Java, Python, C#, JavaScript, or Ruby. Okay, that's a Selenium script. And once we run this script, what will happen is it will interact with for each of the, now it's a Chrome browser, right? There is a Chrome browser. Okay, so this Chrome browser, we need to download a corresponding binary that is available in the Selenium website. We will speak in detail in the next slide. Okay, I will show you a demo how what we are doing. Okay, so we will have this script. The script. Okay, assume this is this. Are you able to see the screen? This is the Selenium script. Okay, this is the Selenium script. The first block is a Selenium script. Okay, once we execute the script, once I click on this execute button, what will happen is it will interact with the browser drivers. For each browser, there is a driver which needs to be downloaded from the Selenium website. Okay, if it's a Chrome browser, we need to download that particular Chrome browser. If it's a Edge, we need to download. Firefox, we need to download. And there are several browsers, and it also depends upon the browser that is being installed in our system. We need to download the corresponding browser version. Our script will interact with the browser driver, which is nothing but a driver, which is a form of exe. Okay, we will interact with the driver, which in turn will interact with the Chrome browser. In Selenium IDE, we saw, right? So it interacts with the Chrome browser directly. But internally, what happens is there would be a binary that would be downloaded from the Selenium website for each browser version, for each browser type, and that driver would interact. We call it as a driver. That driver would in turn interact with the Selenium, with the browser, with the corresponding browser, and perform the user navigation that is being written as a script. Okay, got it?